Now let's take a look at line of best fit. The line of best fit is a straight line that has a few properties. Alright? So the properties of best fit. Properties. Okay, the first one. The line must passes through as many points as possible. Alright? Line passes through as many points as possible. Alright? Then the second property is that the number of points that do not lie on the line should be more or less the same on both sides of the straight line. Point that are not lies on straight line should be more or less the same on both sides. Okay, meaning is this is the graph. So these are the point. So line best fit is here, right? So the line passes through as many points as possible, right? This line passes through 2 points, and the point that is not lying on the straight line should more or less the same on both sides. So 2 at the left side, 2 at the right side. Alright, this is the typical example for the line of best fit. Now let's take a look at these questions. Based on an experiment, the corresponding value of two variables x and y are obtained and recorded in the following table. Alright, this is the table. 20, 30, 40, 50, 60, 70, and y is 108, 110.4, 112.4, 114.4, 116.8, and 119.0. So two parts of questions. First part, plot the graph of y against x and draw the line best fit. Part B, hence form an equation of the straight line. Alright, so now let's use the graph paper. So y against x-axis, y and x. Alright, so here 20, 30, 40, 50, 60, and 70. So here we start from 0, 10, 20, 30, 40, 50, 60, and 70. Right? Then y-axis 108 until 119. So we start from 100. Each cube, each square, we give it 2. Alright? So 100 to 120. So let's find out where is the point. When x equals to 20, y equals to 108. 20, 108 is over here. Put a cross over here. Then 30, 110.4. 30, 110.4 is over here. Right? One small box is equals to 0.2. Then 40, 112.4. 40, 112.4 over here. Then 50, 114. 50, 114.4. 50, 114.4. Right? 60, 116.8. 60, 116.8 over here. Then 70, 119. 70, 119 is over here. Okay? Line best fit. So we draw this line. And then we extend this straight line all the way touches y-axis. So this is the line best fit. As you can see, 1, 2, 3, 4, 4 point lies on the straight line, whereas 2 point lie outside the straight line. Then we have done the first part of questions. Second part, form the equations of the straight line. So equation of straight line is part B, y equals to mx plus c. Alright? So what is the gradient? We use this point and this point, which is 20 and 70. Alright? So gradient m is equals to 119 minus 108. We use 70 and 20 from this straight line, right? These 2 points is also lie on the straight line. Then we use these 2 points. 119 minus 108 over 70 minus 20. 70 minus 20. How much we get here? 119 minus 108 is 11. 70 minus 20 is 50. So how much we got here is 0.22. Then the reason why we want to extend the straight line towards y-axis is because at y-axis x equals to 0, right? So here we can see at y-axis x equals to 0, then y equals to, see the line over here. The line over here is 102 here, 103, 103.2, 103.4, and in between 103.4 and 103.6. So it should be 103.5. Alright? So y equals to 103.5. Therefore, we have the m, we have the x, we have the y now. Now we can look for c. So when y equals to 103.5 equals to m is 0.22, x is 0 plus c. Therefore, c is equal to 103.5. And then the equation of straight line is y equals to m is here 0.22x plus c is 103.5. 103.5. Now let's take a look at these questions. An experiment is carried out to study how the length ycm of a spring changes with the weight F Newton it carries. The following table shows the values of the length of the spring ycm and the weight F Newton obtained. So this is the table. It is known that the length of spring is related to the weight it carries by the equations y equals to AF plus B, where A and B are constant. Part A. Draw the graph of y against F. Part B. From your graph, find the value of A and B, the original length of spring when all the weight is removed, the weight when the length of the spring is 10.8 cm. Alright, so let's do the first part of the questions. Draw the graph y against F. Alright, so y against F. So this will be the graph. So we can see the Fn is, F Newton is 30, 40, 60, 80, 90 and 120. So this will be 20, 40, 60, 80, 100, 120 and 140. Alright? So at this is the f-axis, alright? This is the y-axis. Then the YCM will be 7.8 until 14.2. So we start from 0 until 16. Alright? So when f is equals to 30, y equals to 7.8. 30, 7.8. 30 is over here. 7.8 is over here. Then 40, 8.7. 40, 8.7. 2, 4, 6, 8.7 is over here. Then 60, 10. 60, 10. 80, 11.4. 80, 11.4 is over here. Then 100, 12.7. 100, 12.7. 2, 4, 6, 8. Okay, in between here. Then 120, 14.2. 120, 14.2. Alright, now let's draw the line best fit and extend it to the y-axis. So this will be the line. Alright, so first part A of the questions we have done. Then part B of the questions, find the value of A and B. Alright, y equals to AF plus B. Alright, A is a gradient. Alright, so part B, part 1, gradient is A equals to, okay, let's take 30 and 120. Alright, 30 and 120. Y-axis 14.2 minus 7.8 over 120 minus 30. 120 minus 30. How much you get? 14.2 minus 7.8. We get 6.4. 120 minus 30, we get 120 minus 30, we get 90. So 6.4 divided by 90, we get 0.071. So A is equals to 0.071. How about B? Alright. So B, we use this as this point. Alright. At Y axis, x equals to 0, y equals to, so here 4, 5, 5.2, 5.4, 5.6, then this is 5.7. Alright, y equals to 5.7. Alright, then substitute x and y into these equations. So y equals to 5.7 equals to A is 0.071, x is 0 plus B. Therefore, B is equals to 5.7. Then second part, the original length of the spring when all the weight is removed. Alright? Meaning, when x is equals to 0, sorry, this is when f equals to 0, this is 0 as well, this is f as well. Alright? So when f equals to 0, all the length, all the weight is removed. Then what is the length? What is the original length? Alright? So y equals to AF. A is 0.071. F is 0 plus B. B is 5.7. Therefore, Y equals to 5.7 cm. Alright? Meaning, when all the weight is removed, the original length of the spring is 5.7 cm. Then, last part of the questions, when the length of the spring is 10.8. Alright? Length of the spring 10.8. 10 here, 10.8 is over here. Let's draw a line. 10.8 is over here. Okay? When this dotted line touches the line that we draw a straight line to the f-axis. Then how much we get? 60, 70, this is 72. Therefore, when the length of the spring is 10.8 cm, the weight is 72 Newton. Now let's take a look at these questions. An experiment is carried out to study how the length ycm of a spring changes with the weight F Newton it carries. The following table shows the value of the length of the spring ycm and the weight F Newton obtained. Alright, this is the table. It is known that the length of the spring is related to the weight it carries by the equations y equals to AF plus B, where A and B are constant. Part A of the questions, draw the graph of y against F. Part B of the questions, from your graph, find the value of A and B, the original length of the spring when all the weight is removed, and the weight when the length of the spring is 10.8. Alright, let's do the first part of the questions. Draw the graph of y against F. So this will be the graph. Y-axis is y, x-axis is Fn. Right? So Fn we have 30, 40, 60, 80, 90, 100 and 120. So we do 20, 40, 60, 80, 100 and 120. Alright? Then y-axis 7.8 until 14.2. So we start from 0 until 16. Draw the graph. Okay. 30, 7.8. 30 is over here. 7.87 is here. 7.8 is here. 40, 8.7. 40, 8.7 is over here. 60, 10. 60, 10. 80, 11.4. 80, 11.4. 100, 12.7. 100, 12.7. 120, 14.2. 120, 14.2. Alright, let's draw a line best fit of all these points and then extend it to the y-axis. So this will be the line. Right. Okay, first part of the question we already done. Then second part, find the value of A and B. Alright. Y equals to AF plus B. So A is a gradient. So A is a gradient. Part B. Part 1. Okay. Gradient. A equals to, which one we want to use? Let's use 30 and 120, these 2 points, alright? So 30 and 120. Y-axis is 14.2 minus 7.8. 14.2 minus 7.8 divided by 120 minus 30. How much we get? 14.2 minus 7.8, we get 6.4. 120 minus 30, we get 90. So 6.4 divided by 90, we get 0.071. So A is 0.071. Then how about B? So how do we find B? B is a constant. So let's use this point, alright? So at y-axis, x equals to 0. At y-axis, f is equals to 0. Then y equals to, take a look at this point. So this will be 5, 2, 2, 2, and 2. So 2, 4, 6. So it will be 5.7. Alright? 5.7. Then substitute 0 into f, y substitute 5.7. So we get 5.7 equals to A is 0.071, f is 0 plus b. Alright? Therefore, b is equals to, this whole thing equals to 0, b is equal to 5.7. Second part of the questions. The original length of the spring when all the weight is removed, meaning F equals to 0. So F equals to 0 here. So this is the point, alright? So when F equals to 0, Y equals to A is 0.071, F is 0, plus B is 5.7, so Y equals to 5.7 cm. Okay, 5.7 cm is the original length of the spring when all the weight is removed. Okay, third part of the questions, the weight when the length of the spring is 10.8. Alright, length 10.8 is over here. Draw a straight line towards the line best fit. This dotted line towards the line best fit. When the dotted line touches the line best fit, we draw another dotted line towards this F axis. So from here we get 72, alright? So when the length of the spring is 10.8 cm, the weight is 72 Newton. Alright? So if you have any questions regarding this subtopic, feel free to comment below this video and we will further explain it to you.